Hello guys, welcome to the channel. In this particular video, I have explained the problem seating arrangement. So let's get started. Okay, so here is the problem statement. Pretty simple and straightforward. It says that you are given an integer n denoting the number of people who needs to be seated. Now, and a list of m integer seats where 0 represents a vacant seat and 1 represents an already occupied seat. Okay, and your task is to find whether all n people can find a seat, provided that no two people can sit next to each other. Okay, so let me explain the problem with this particular example. So basically we are given n people, so n is 2 here, we are given 2 people and we are given some seats, so we are given 7 seats for this particular example, and the seats are like 0 represents an available seat and 1 represents an already occupied seat. So we have the seats like this. Now out of these seats I need to provide 2 seats to 2 people here so that all people get a seat. Okay, now the task is simple. What I can do is I can try to provide seat, the first seat to first person and the second seat to second person. This way I will have the arrangement like 1 1 1 0 0 0 and 1, right? But hold on, there is a problem. The problem is these two people are sitting next to each other. Even these two people are sitting next to each other. But according to the problem, it says that no two people can sit next to each other. So we can't do something like this. This is not valid. Okay, so what is a valid arrangement? The valid arrangement is we can provide the first seat to the first person and this seat to the second person. This way I will have arrangement like 1 0 1 0 1 0 1. You can see that for this arrangement no person is sitting next to each other. Okay, so this is a valid arrangement, and if we are able to like write one valid arrangement, this means that all n people are able to find a seat, so output is going to be yes in that case. Okay, now I hope you have understood the problem well, so let's talk about the solution. Here I have taken the same example where we have two people that needs to be seated and we have 7 seats available. Let me write this array here. So I'm going to write this array and the values are 0 0 1 then 0 0 0 1. Okay, so our task is to provide seat to n people, right? So first of all we can look for empty seat in the array, in this particular array. So what we can do is we can write the code as looking for empty seat means we can write for I equals to 0, I smaller than m and I plus plus. This way I can look for all the empty seats. And now inside this I can check if seats of I equals to 0. This is basically going to give me whether the seat is available or not. So you can see that if I write this particular code, then inside this I will have all the empty seats, right? Okay, and if I have an empty seat, what to do then? I need to provide that seat to a particular person, right? Okay, but how to provide? There's a condition that I need to take care of, that no two people get like no two people sit next to each other, right? So if I provide, in this particular case, if I provide this seat to a person, this way I will have two people sitting together, fine. And if even if I have 0 1 0, then you can see that there is no any seat that I can provide to any person. But if I have arrangement like 0 0 0, so you can see that this is available, this is available, and this is also available. So if I provide this seat to a particular person, in that case I will have a valid arrangement, right? Okay, because there is no person which are sitting next to each other for this case. So I can look for this case. Looking for this case means I will check if okay, so let me change the color. I can simply do one thing, that I can check if seats of I minus 1 is available and seats of I plus 1 is also available. I plus 1 is also available. This is what I can do. And if the seats of I minus 1 and I plus 1 is available, like in this case, so I can provide the ith seat to a person. How to do this? How to provide seat to a person? So first of all, I can simply decrease the count. Decreasing the count simply means that there is n minus 1 person left now. Fine. And after this, I can occupy that seat. So I will make seats of I has become occupied now. So the value will change to 1. Fine. And one more thing that I can do is, since we are decreasing the value of n here, so I can check if n has become equal to 0 or not. So if this is the case, then in that case, I can return true. Why return true? Because no person is left now. Okay. So this code snippet is basically used to provide a seat. Okay. Now you can write this code in order to get your problem accepted. Is it the case? No. This is not going to work. There's a problem. The problem is I'm checking for seats of I minus 1 and seats of I plus 1. But there is a problem. The problem is if I'm at starting value, uh, if I'm at this particular position, in that case, seats of I minus 1 is not there, right? Okay, and for this particular case, seats of I plus 1 is not there. So now I have divided the array into three parts. The first part is for I equals to 0, because for this seats of I minus 1 is not available, and for this seats of I plus 1 is not available. But for the middle part, this condition is going to work fine, because seats of I minus 1 is available and seats of I plus 1 is also available for every value here. Fine. Now I need to handle case for these two parts. So what I can do is I can first of all check, uh, I can check if I equals to 0. So if I is equal to 0, if I is equal to 0, and else if I equal to m minus 1, m minus 1. This is how I can handle case for all the values. Fine. What to do inside these? If I is equal to 0, in that case, I can't check for this condition, but I can check for the next seat, right? So I will check for next seat. I will check if seats of I plus 1, seats of I plus 1 is available. In that case only I'm going to provide a seat. So providing a seat simply means writing this particular code here. So we can write this here. And for this particular case, I equals to m minus 1, which is this area, I can write if seats of I minus 1, because I can check for this particular previous seat. So if seats of I minus 1 is available, in that case again I can provide seats like using this code. So this is the whole thing that we need to do in order to solve the problem. At last, if like n is not equal to 0 for any of these condition, in that case I can surely say that my answer is not true. So I need to return false. But there is a problem in it, in returning false. Let's say I have 0 0 0 0. So I can provide first seat here, then I can provide the second seat at this okay, so then I can provide the second seat at this position. Okay, so when my n becomes 0, then the loop is over. So I can check at last if my n is equal to 0. In that case only I need to return true, else I can return simply false. Fine. So this is the code that I need to write. Okay, so now let me show you the code. This is the code that we need to write in order to solve the problem. On the left hand side, I have written the Java code, and on the right hand side, I have written the Python code and the C++ code. So let me start with the C++ code first. You can see that these are the three conditions that I need to handle. What does this condition means? Let me explain the conditions. The first condition is, okay, so let me make some space here. Now, now the first condition is if n is greater than m. This condition basically means that let's say we have 20 seats here. Okay, and out of 20 seats, some are available and some are not available. So let's say all are available. Okay, and we need to we need to provide seats to 100 people here. So is it possible? It is never possible. You can see that n is greater than m. So if the person are more, in that case I'm always going to return false. Fine. The second condition is if my n is equal to 0. If my n is equal to 0, let's say n is 0, so I don't care how many seats are available, because I have at least the value of m as 1. So I don't care how many seats are available. If n is equal to 0, there is no person who need to get a seat. So I'm always going to return true for this case. And there is one more case. There is one more case. If my m is equal to 1. If my size is equal to 1, let's say I have seat 1. seat of size 1. So there are two values possible, either this value is 1 or this value is 0. So if this value is 1 and I need to provide seat to people, two people, so is it possible? Okay, so this condition is going to true for this case. If I need to provide the seat to one people, in this case you can see that this is not possible, right? Because this seat is already occupied. So and but if this value is 0, in that case only it is possible. So there are two values possible, either 1 or 0, and we are going to return true only if seats of 0 is equal to 0. These are the three conditions that I need to take care of. Okay, so now I can show you the code. So the first of all, I have handled these three conditions, and after this I have initialized my I as 0, and I'm just looking for the empty seats. Okay, so now the first case is if I is equal to 0, the second case is if I is equal to m minus 1, and the third case is if these two cases are not true. This is a middle area, right? Okay, so I'm checking the value if previous and next seat are available. In that case, I can write this particular code in order to provide a seat, and the same code I'm writing here as well and here as well. You can see here. Fine. Now this is how we are going to solve the problem. So you can see the C++ and Java code here, how we are going to solve the problem. Now let me show you the Python code. This is the Python code that we have. I have handled these three conditions first, and after that I'm just doing this particular stuff in order to solve the problem. Now I hope you have understood the problem well and the approach to solve the problem. So this is all about this video. If you guys like the explanation, then you can hit the like button and subscribe the channel. Thank you.